Hi there, this is an Algebra 1 video. It is Chapter 7, Section 4, and today we are going to be discussing scientific notation. And I know that most of you have probably dealt with scientific notation, probably in middle school. And so I just kind of wanted to recap real quick here what scientific notation is. Scientific notation is basically when we take really, really large numbers or really, really small numbers and write them in a more simplified way, I guess. It can get really long to write all of this, for example, all those zeros, part B as well. So we have a way that we can actually write them a little bit smaller, make it a little bit more simpler. So basically a number is considered to be in scientific notation when it's in this form, a times 10 to the nth power, and the a value that is in front of the times 10 part needs to be a number that is greater than or equal to 1, but at the same time less than 10. So we don't want it to equal 10, but we want it to be less than 10. Also, n needs to be an integer. So it can't be a rational exponent like the last lesson. So we're going to do some examples here. I did want to put up here, just in case you were wondering, it depends on which direction you're going. We have numbers that are considered standard form, which is what we have in example 1. So if you want to go from standard form to scientific form, basically what you need to do is move the decimal either to the left or to the right. You want the decimal to move until the decimal point is to the right of the integer that you're trying to get. So we want to move the decimal point until it is to the right of the first non-zero digit. So for example, in this case, I would, if there's no decimal in the number, we assume it's at the end. And so if I move the decimal, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Now the decimal point is to the right of the first non-zero integer. So that's what we're looking for, the non-zero digits. And we moved it 3, 6, 8 times. So now we're going to put 2.01 times 10, and we're going to put 8. Because according to this, we know that if we move the decimal to the left, which is what I did, I had to move it in the left direction, then we're going to put a positive n. If we have to move it to the right, we're going to put negative n, and that's going to happen in part B. So here's my decimal. I'm going to move it 1, 2, 3, 4, 5, because the decimal needs to always be to the right of the first non-zero digit, which in this case is 5. So because I moved it 1, 2, 3, 4, 5 times, we're going to write 5.1 times 10 to the negative 5, because this time the decimal moved to the right as opposed to the left. So now if you can try to do it yourself, number 1. We're going to go backwards now. What if we have something in scientific notation and then we want to put it in standard form, which is what we have in example 2. So when you're going the other direction, scientific to standard, you still want to move the decimal, but if you're going to, when you move the decimal, you're going to have to move it, again, left to right, and it depends on what this number in front of the decimal is. So the rule of thumb is, we have to figure out, is the n value, this guy right here, this is our n value, the 9 and the negative 7, is our n value greater than 0 or less than 0? Is it positive or negative? So in part A, our n is 9, so that's greater than 0. So that means we're going to move the decimal to the right. So that means I'm going to take my 6.32, and here's my decimal, and I'm going to move it 9 spaces to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to fill it in with zeros. So it'll be 6, 320, 0, 0, 0. So there we go. I'm not actually, I know this is a millions, and I know this is billions, trillions, I don't know what that number is, but it's really big. And so basically, again, the first thing you want to do is make a note of whether or not the n value is greater than 0 or less than 0. If it's greater than 0, then move the decimal to the right and fill it up with zeros. If it's going to be less than 0, like negative 7, which is less than 0, then you're going to move the decimal to the left. So in that case, I'm going to have a 4. And the decimal, if there's no decimal present, we always assume it's at the right side of the 4. So here's the decimal at the end of the number, and I'm going to move it to the left 7 spaces. So 1, 2, 3, 4, 5, 6, 7. And then fill it in with zeros. So this time my answer is 0.000004, I think. 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5. I'm missing a 0. 4. That'd be my answer. Alrighty. So that's pretty much how you do that. It's not very complicated. So now I want you to try do yourself number 2. And then we're going to go into multiplication. How do we multiply two numbers that are in scientific notation? So what we're going to want to do is to basically rewrite this little problem. So what I'm going to do is I'm going to take the 3.5 and the 7 and multiply those. And then we're going to have the 10 to the negative 3 times the 10 to the 5. Like that. So what that's going to give me, I don't know why I grabbed my phone and my calculator. We're going to go 3.5 times 7, which is, this gives me 24.5. And we know that when we have the same base and we're multiplying, that we add the exponents. So that's going to be times 10 to the 2, because negative 3 plus 5 is 2. But then, as we look at our first portion, this 24.5, this is not in scientific notation, because the 24 is bigger than 10, and it's supposed to be less than 10. So we need to move this decimal 1 unit to the left, and because we move it to the left, we're going to get 2.45 times 10, but to the 1 power. And again, that's going back to our previous rule that if we move the decimal to the left, that we have a positive end value there. So we have, I'm sorry, I didn't even put the times 10. We want 2.45 times 10 to the 1. So basically 24.5 is the same thing as 2.45 times 10 to the 1, and of course we still have times 10 squared. So now we can write our final answer as 2.45. And again, because we have the same base, we're going to add the exponents, and it's going to be times 10 to the 3rd power. And there's your final answer, 2.45 times 10 to the 3rd. Now it does ask us to express the result in both scientific and standard form. So this is a scientific notation. If I wanted to do it in standard form, then I would have to move the decimal 3 units to the right, so it would be 1, 2, 3. So in scientific notation, it's 2.45 times 10 to the 3rd, but in standard form, it would be 2,450, because I would move the decimal, that would be right here between the 2 and the 4, 1, 2, 3 times, and you would get 2,450. So I want you to express it in both forms. So now you can do yourself number 3, and we'll go to our last example, which is dividing scientific notation. It's done very much the same way that multiplication was, in other words, 2 pieces at a time. So we are going to take the 3.066 and divide that by 7.3, that's one portion. And then we're going to take the times 10 to the 8th and divide by 10 to the 3rd. That's the second portion. So 3.066 divided by 7.3 is 0.42. 0.42. And when you're dividing with the same base, you subtract the exponent, so 8 minus 3 is 5. And we get that. But again, like before, the 0.42 is not considered to be in scientific notation because 0.42 is not bigger than 1. Remember, it needs to be bigger than 1 or less than 10. So again, we're going to have to move our decimal 1 place to the right. And because we're moving it 1 place to the right, it's going to be 4.2 times 10 to the negative 1. And then, because we still have the times 10 to the 5th, we can finally get our final answer to be, we're going to add the exponents, negative 1 and 5, so we're going to get 4.2 times 10 to the 4th power, and this is going to be our answer in scientific notation. And to have our answer in, excuse me, in standard form, we have to move the decimal 4 units to the left. So 1, 2, 3, 4. So we're going to get 0.123 like that. In other words, I would have to go 1. I'm sorry, I just did that backwards. La 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 la. Please forgive me. I need to move it 4 units to the right. So if I do that, I'm going to get 4, 2, that's going to be 1, and then 2, 3, 4. So you're going to get 42,000. All right? I'm not sure why I was going backwards. But because this is a positive 4 up here, I think I was thinking it was a negative 4. But because this is a positive 4, we're going to move this decimal 4 units to the right. And so if the decimal was originally here, that's 1, 2, 3, 4 units to the right, and you get 42,000. Basically, when your exponent up here is positive, it means the number is really big. And when the exponent up here is negative, it means that the number is really small. So that's how I was able to catch that mistake. So now you'll finish doing yourself number 4, and once you have done that, you will have completed your notes for this lesson. And I will see you in class, and thank you for watching.